Good morning, everyone. My name is Ansh Goel, and my roll number is 1018060041. As a part of my capstone project, I am doing research on design and analysis of Meminductor Emulator, and my mentor is Dr. Shireesh Kumar Rai. Now, moving forward, first of all, we will see what we are going to see in this presentation. We'll start off by introduction, and then moving forward, we'll go to the references. Now, starting with the introduction. So what do we mean by mem elements? Mem elements is basically an acronym for memory. So any passive element that can store memory is a mem element. So like mem resistor, mem capacitor, and mem inductors are formed by combining the words memory plus resistor, memory plus capacitor, and memory plus inductor. So these are the elements that can store information without the need of any external power supply, allowing low computation and storage. So these are the symbols for all the three which we discussed in this presentation, which are mem resistor, mem inductor, and mem capacitor. Now moving forward. So this is the literature survey of mem inductor. As you can see that the work started in 2009 and it is a relatively new topic because all the research that has happened and all the emulators made or all the applications were primarily focused on mem resistor, but here we are emulating mem inductor, and we have also used that proposed MEMELEMENTS in designing the application, which is a chaotic oscillator, which we are going to see in the coming slides. So this is the literature survey. Now moving forward, MEMELEMENTS emulator. What do we mean by an emulator? An emulator is a hardware that mimics the property of a device using the commercially available circuits. So MEMELEMENTS is still not available as a device form, so we have to emulate it. That is, we have to mimic its property using the already available analog building blocks, which we'll see in the coming slides. So the objective of this research was very simple and explained in these 2 points, which were to design a simple grounded MEMELEMENTS emulator circuit without using an analog multiplier. And secondly, the realization of chaotic circuit using proposed MEMELEMENTS emulator and validate its performance. So first we have designed a MEMELEMENTS emulator and followed by which we have used it in the application, which is the chaotic oscillator. Moving forward. So the analog building blocks which are used by us was OTA. OTA is an operational transconductance amplifier, which is a voltage controlled current source. And its property is that its transconductance is directly controlled by its input bias current. So this is the block diagram and this is the transistor implementation. And this is the equation which governs an OTA. The transistor model for all the of all the blocks are done by us using the LT-Spice software. Now moving forward, the CC2. CC2 stands for second generation current conveyor. It is also made by us using LT-Spice. It transfers the current from the input terminal to the output terminal. It has two input terminals and one output terminal, and we can see that IX and IZ will be equal and they'll be opposite in direction. So we use the negative sign. This is the transistor implementation of the same. Moving forward with the CDBA. CDBA stands for current differencing buffered amplifier. It is a multi-terminal device with two inputs and two outputs. It takes the difference between the currents and buffer it to the output. So same, this is the block diagram and this is the transistor implementation. We can see that IP minus IN is buffered here as also given in the equation. Now moving forward, so this is the proposed design of MEMELEMENTS emulator. We are using an OTA, second generation current conveyor and CDBA along with some linear passive elements like capacitor and resistors. And the V in by In, that is the impedance we got for this circuit, is S times the constant, which mimics the property of an inductor. Now moving forward, so what is the result that we expect from MEMELEMENTS emulator? The result which we expect is a pinched hysteresis loop, which I'm going to show in the next slides. Hysteresis loop shows that the element remember the recent values and start operating from the value when switched on again. So we have plotted the graphs for different frequencies and it is done for both the incremental and decremental MEMELEMENTS emulators. So now the simulation result, you can see these for the incremental MEMELEMENTS emulators and the frequency are given in the graph. This is the current by flux graph. And we can see that the graphs for both are in the opposite direction. That is for the incremental, if the hysteresis loop is like this, for the decremental, it is in the opposite direction. That is, the value of inductance decrease as we go on switching on the power supply for the decremental, and for decremental, it is quite opposite of what I have just said. That is, on increasing or on powering of the MEMELEMENTS emulator, its inductance increases. Now moving forward. So the application which we have proposed is a chaotic oscillator. It took the most of the time. So a chaotic oscillator is a non-periodic oscillator that produces an oscillating waveform, unlike the ordinary electronic oscillator. So these are the conditions that we need in order to make the chaotic oscillator, and all these three conditions are uh, verified and used by our Meminductor emulator. So this is the Meminductor emulator that we used, or this is the design. As you can see that this is the application which we used, and this is the proposed Meminductor emulator used in this chaotic oscillator circuit. Now moving forward. So these are the results which we got, and as you can see from the results that it follows the chaotic oscillator behavior, but it is not periodic as mentioned before. So this is the I versus V graph, and this is the V versus P graph of the same chaotic oscillator circuit. Now this is the flowchart, as you can see. So these are the work that we have done. Literature survey, research gap. After finding the research gap, we implemented the analog building blocks. Then the design of the Meminductor emulator, design verification. And if it didn't work, then we have to design it again. And same for the chaotic oscillator circuit. And after finding the research gap, we studied the evolution of Meminductor and the spice model of the Meminductor as well. So this is the Gantt chart. As you can see that the problem solving took most of the time. And we have communicated the paper in the Iranian Journal of Electronic Science and Technology in the November of 2021, and we expect the results from them as soon as possible. So the conclusion that we get is Meminductor is basically a device that is very helpful, and we have shown it using chaotic oscillator circuit that it works and it can be used in making the applications. And we have designed several filters as well and neuromorphic circuit as well, and it works very well in all the applications. The one used by us used the already available analog building blocks, which are the OTA, CDBA, and TC2. So these are the references. So I want to thank each and every one of you for listening me so patiently. Thank you so much.